Hello. So this is the third part of video. In this video I'm going to talk about the algo round, which is basically the implementation of algorithm. So algo round has three main parts, these three, and that is data in, which is getting data from on the outside this top.vhd file, and the signal that is providing data is data to encrypt. That is a signal here, data to encrypt, right? And we have one process here, this process. So that says data to encrypt. Whenever the count equal to 1, then data to encrypt will be plain text XORed with generated key. This generated key is being passed from the key generator here. This key generator is sending key to key generated key, this one. So that is being XORed with the plain text, and this plain text is the signal here, plain text. This is the original data that we want to encrypt. So right now I have just assigned to 0, 0, 1, 1, 2, 2, 3, 3, like that up to FF. Right, so that is total 128 bits that is being passed here. This generated key, data to encrypt, generated key, and this would be the output of the encrypted data, would be the output. So let's see this algo round file. Algo round here. So this is algo round file. Basically it has 4 different sub processes in each round, right? So, and those 4 processes is the first one is substitution of byte, or byte substitution, right? And that basically has 16 S boxes. Let's see that part here. So we have algo round file. As I said, we have 16 S box, right? So again, this is a port for algo round, right, that we already saw. Then this architecture, these are 2 signals that we're going to use later on. First signal is sub byte result, that is nothing but the result after we got byte substitution, right, output of 16 S box. Then the second one is shift row result, that is the result after shift row operation. So the first thing is component S box. We have also included S box here, right? And the second component is shift row. Shift row is for the second operation. Here we can see the shift row operation, right? So that is for, we have a separate file for that shift row. So first thing here is I have instantiated 16 S box here for I in 15 down to 0. Generate 16 S box, and the port mapping is done here. We can change different values of I here, and that way we will port map the bunch of 8 bits to each S box as an input and output. And here we can see the output of S box is being assigned to sub byte result, right? So that is the output. Sub byte result is here, sub byte result, output of 16 S box. So output is being assigned here, right? Then we have the output of byte substitution is the input to the shift row. See here, sub byte result is input to the shift row, and that shift row file I have here. Shift row is basically the second operation here, shift row, right? That also has 128-bit input, which is this one, and 128-bit output is this one. So let's see the shift row file. So this is a shift row. What's in shift row file? So as we say, like we have 128-bit input, right? We can divide it into 16 byte, 0 to 15. So 0 to 15, right? And 0 to 15, as we can see here. So here we are interchanging the byte number. So if we have this input, then this is how it should be the output on the right hand side. The matrix byte out is eventually would be the output, and this is the input. So we can see like the first row will be as it is, 04812, 04812. The second row is shifted left by 1 byte. We can see 15913 is now 5913 1. The third row is shifted by 2 places. So we have 10 14 2 6, and the fourth row, last row, is shifted by 3 places. So this is by 1 place, this is by 2 place, and this is shifted left by 3 place, right? First will be stay as it is. So this is what we are doing here. The matrix byte out and matrix byte in. Matrix byte in, so 0 is assigned to 0, fifth one here, fifth one is assigned to 1, right? 10th is assigned to 2, 15 3, and for all 15 of them. And then at the end we are assigned that matrix byte out, different matrix byte out, to the shift row out. We can change the value of I here, and accordingly we will be having particular value assigned to this signal, and that would be the output here, shift row out. That will be assigned to shift row result. So this is what I have done so far. The next step would be generate the separate file like this shift row, right? Shift row operation. I will be having a different file for this add column operation, right? this mix column operation, that is the third operation. And then this add key is nothing but the XOR of whatever would be the output of mix column, and that would be XORed with the key here that is being passed, right? So I still have to make the file for mix column, right, which is not ready yet. So far this is what I have done, and in the next video we will see the output by simulating this code, so that we can get the idea what's happening.